morning. Hi. So y'all are wonderful second period. It is the 6th of May, and today we're going to be talking about solving rational equations. Before we dive in and actually start solving these things, you need to be reminded of one thing. The word rational means fractions. Basically, we're going to be solving fractions equations. So equations with fractions. We have 3 different ways to do this. So far, we've taught you one way. The one way to deal with fractions in an equation is to get rid of the fractions in an equation. And that remains the best method to dealing with rational equations, is just get rid of the fractions. What's the method that we've given you so far to get rid of fractions in an equation? Setting the equation equal to 0 is for quadratics, when you have x squared. Say what with the denominator? Yeah, multiply everything by the denominator. Good. And that's what we're going to be doing here. Except now it's entirely possible that we're going to have multiple fractions and different denominators. So when we have more than one fraction, and these fractions all have different denominators, we're going to use the least common denominator as the thing that we multiply by in order to get rid of all the fractions. Okay? All right. There's 2 other methods. The second method is rename all fractions with a common denominator. Once we have all the fractions rewritten and renamed so that they all have the same denominator, we can get rid of the denominators and you look at just the numerators. That's the technique I like the best. The final one is rework the equation, doing whatever you need to do so that it is 1 fraction equals 1 fraction. Because after that, you cross multiply. Okay? So if it's a bunch of stuff equals a bunch of stuff and you've got some fractions in the stuff, take each side, do whatever you got to do so that it becomes 1 fraction. Do that to each side. Cross multiply, you're done. All right? Before we jump into this, a real quick recap and recall on some fractioning, on some factoring. In particular, sum and product. All right, we have this thing. Let's practice factoring this. Sum and product requires us to do A times C. This is A, this is C. A times C is 1 times negative 40. 1 times negative 40 is negative 40. And all the factor pairs of negative 40, that add up to give me a negative 3. I'm sorry, you're right, a positive 3. My goodness. Yeah, negative 5 and positive 8 give me a positive 3. So I'm going to split this up into 2. We have x squared here negative 5x, positive 8x. Factor by grouping. Now if you're already seeing the shortcut on this and you're able to jump from where we're at now to where we're going to be in a little bit, then by all means, please do use that shortcut. I will be using the shortcut for the rest of the day once I finish this one, just so that you can see all of the factoring. Okay, it's factored. Remember that? Do you need some line paper, Sam? Do you need some line paper? Okay. Yeah, easy enough? Alright. So then let's practice doing this whole getting rid of fractions and equations, solving these rational equations now that we've recalled our factoring. Alright, the directions say solve. Our first equation looks like this. Which is a mess. It's all fractions. We've got variables sitting everywhere, and oh my god, right? Our first technique says multiply by the denominator. But we have multiple fractions with different denominators, so we need a common denominator. What are you thinking? Yeah, let's build a common denominator. The way we're going to build a common denominator is look at each denominator in turn and try to figure out what are all the different factors that appear. In this one, I see an x as a factor. In this one, I see a 3 as a factor. In this one, I see an x as a factor. The x was already listed down, so I don't need to write it again. And so my common denominator is 3x. So I'm going to multiply everything by 3x. Gentlemen, put the phones away, please. Thank you very much. So I'm going to multiply this by 3x, and this by 3x, and this by 3x, everything in the equation by my common denominator. So then this fraction becomes 3x over x. This one becomes, okay, I'm going to write 13 times 3 times x. I know it looks really stupid right now, but bear with me. You'll see why I'm writing out everything and not actually figuring out the numbers, okay? From here, I'm going to start eliminating things in numerators and denominators that are the same. In this fraction, there's an x in both numerator and denominator. That can go away. In this one, I have 3 in both numerator and denominator. It can go away. In this one, I have x in both numerator and denominator. It can go away. And so my equation becomes 3 plus 13x equals 21. Then I can solve this equation down for x. Do y'all need to see this one solved, or you're okay? You're okay? Okay. So, solve it for x. Subtract 3. Divide by 13. Yeah, 18 over 13, and it's fine. Leave it as a fraction. All right, so this was technique number 1. The second one says rename all the fractions with a common denominator. Shall we do this one again? Yep, with the same technique? Okay. So, same technique, same fraction. So the fraction was that. And we already decided that the common denominator for this thing was 3x. So if I'm going to rewrite all of them so that the denominators are 3x, I need to figure out what's missing in each denominator. For the first fraction, what's missing from x to make it 3x?
3.
The 3, so I'm going to multiply the top by 3. In the second fraction, what's missing from the denominator to make it 3x? The x. And in the second fraction, the 3. All the denominators are the same in the equation. Get rid of the denominators. And my equation turns into 3 plus 13x equals 21. Exactly what I had gotten here. Okay? Two different techniques lead you to the same place. I prefer the second one. That's just me. Yeah, it just feels easier to me. Because then I get to be like, bye denominators, and move on with life. All right, let's show you the third one. Rework it so that it is fraction equals fraction. And again, I'm going to grab the same example so that you can see what it looks like. All right, now we're going to use technique number 3. We're going to rework it so we have one fraction equals one fraction. I don't need to do anything on the right side of the equation. It's already a fraction by itself. So I'm just going to play with the left side. In order to add those fractions, I have to have a common denominator. We've discovered already that the common denominator was 3x. And from the second example, I already saw that it turns into this. Okay? I'm going to add them together. Oops. I have it as... I don't add the 3x's together when I'm adding fractions. Where did I get that? Was the common denominator? Because this is the same example. Now that I have it as fraction equal fraction, cross multiply. Those two things multiplied together equal these two things multiplied together. And then I can distribute and collect like terms, move everything to one side if it ends up being an x squared kind of thing. Okay? Yeah, and then still solve this down for x. You should end up with 18 over 13 again, because it's the same equations. You're going to have 13x squared. Yeah. So when we do this distribution, you want to see the rest? Yeah. Yeah, we've got some stuff that needs to happen here. Do y'all want to see this one worked out? To confirm? Okay. I've got some nods. All right, so from here, I would rewrite this and then maybe subtract 21 from both sides. So that's going to be negative 18. I'm going to factor this thing. I'm going to use the zero product property. This one's already solved. Now I'm going to look at this one. Move the 18 over, divide by 13.
So to get rid of the x squared, we need to multiply?
I factored. They both had a common factor of x. Yeah, so I factored it out to you. This should feel really weird to you right now, because this was the same equation as the first two examples. And in the first two examples, I had one answer, 18 over 13, and now I suddenly have two. I have x is 0 and x is 18 over 13. Does that feel really bizarre? Like you're sitting there going, why did we suddenly have two answers? and which one is right.
Yeah.
Yeah? I'm so glad that you're thinking that. And it's because equations like this, where you have fractions and variables in the denominator, these kinds of equations have restrictions. They have values that the variable x cannot be. Thinking about fractions, meaning that it's division. What can you not divide by? No, we could divide by x. I mean, we're dividing by x here. 0. We can't divide by 0. So the restrictions are any value of x that make the denominator 0. Any value of x. When we look at the equation, if a value of x would make the denominator 0, that's not allowed as an answer. All right, let's look at the original equation. This denominator, does it have a variable? Yes. So to find the restriction, I'm going to set that denominator equal to 0. And then solve it for x. I did it. It's solved for x. I have to do anything. This value 0 is not allowed as an answer. It showed up as an answer, which means you have to get rid of it. Because it's a restriction. It's a value that's not allowed.
So you're gonna have an answer with it. So
It's entirely possible that one or more of your answers is the same as one or more of your restrictions. You have to find them both. You have to find all of the possible solutions and all of the possible restrictions. And then anytime a solution is the same as a restriction, you throw out that solution. Okay? Let's run a few more examples. Okay? All right, let's look at this one. That's a nice and messy. Wonderful. It looks great. There's a lot of fractions. There's a lot of variables. We have 3 techniques to get rid of fractions in an equation. Multiply everything by a common denominator. Make all the denominators the same.
x plus 2. Plus 2.
Or rewrite both sides so that way you have one fraction equals one fraction and then cross multiply. Which technique would you like to see?
Second.
The second one, the rename everything? Yeah, I agree too, I like it. So my common denominator, you guys have already stated, was x plus 2, and that's because this second fraction has a denominator of 1. All right, renaming everything. All right, denominator, my common denominator is x plus 2. This denominator is already x plus 2, so there's nothing to do. The second fraction had a denominator of 1. I want it to be x plus 2. What's missing?
The x. Oh, no, 1.
What do I need to multiply to 1 to give me x plus 2? I have to multiply x plus 2. So I'm going to take the numerator of this fraction and multiply it by x plus 2. Last fraction. Denominator is already x plus 2, so I don't need to do anything.
So when you
The renaming?
yeah,
Mm-hmm.
you need to do it in the top and the bottom.
Yes, sir. Whatever you do to the bottom, you have to do it to the top. All right, looking at the equation, all the denominators are the same, so I get to ignore them. And I'm going to rewrite my equation as this, which then I'm going to solve for x using any technique I can handle. I'm going to distribute first. I notice that it's a quadratic. I have an x squared. So I'm going to collect everything to one side and leave the other side as 0. I'm going to combine like terms. It's a quadratic equation, it equals 0. I've got 3 different possibilities that I could use to solve it. I can factor it, I can complete the square, or I can use the quadratic formula. I'm going to check to see if I can factor it, because for me, if it can be factored, factor is easiest. For me, because I've practiced it a lot. Okay, a times c, that's 1 times negative 8. Factor pairs of negative 8 that when I add give me negative 2. Negative 4 and positive 2. 4 times 2 is 8. The signs are different, so it becomes negative. And then negative 4 plus 2 is negative 2. All right. My shortcut says now that I have my factors, I can just write it like this. Okay? Zero product property says that when I have it listed like this, I can write each factor equal to 0, and then I can solve. But now I need to check for restrictions. To check restrictions, I'm going to go back to my very original equation, and I'm going to grab every denominator that has a variable in it. This denominator has a variable in it. I'm going to set it equal to 0. This denominator does not have a variable in it. I'm going to ignore it. This denominator has a variable in it, but I've already written it down, so I don't need to do it again. So I only have one restriction. I'm going to solve that for x. This tells me that x is not allowed to be negative 2. Looking at my solutions, do I have a solution where x is negative 2? Yes, that cannot be an answer because it matches a restriction. So even though when I solved my equation it looked like it was a possible answer, my restriction says no, it's not. This has one solution. Okay? I want to do at least one more. Are there any questions on this before I hit the next example? All right. Here's the next example for you. Solve that one. Oh my God, it looks like a mess, right? You've got the variables literally almost everywhere. You've got an x squared in the denominator. Relax, it's just an equation with fractions. How do we get rid of equations in a fraction? How do we get rid of fractions in an equation? Sure, if you'll just leave them here, I'll sign them in just a moment. Thank you very much. How do we get rid of fractions? Multiply by a common denominator. Or rename the denominators to all be the same. Or combine fractions so that you have one fraction equals one fraction. The trick is how do you do it in this, right? That's where you're stuck on. So our first step when we have a denominator that looks like this is going to be to factor it. I'm going to try a times c. So 1 times 6. Factor pairs of 6 that when I add give me 5. 6 isn't, it's not negative. The factors aren't negative. And it's because this middle term isn't negative. So my factors are positive. So the question is it 1 and 6 or is it 2 and 3? It's 2 and 3 because when I add 2 to 3 I get 5. So then this factors to x plus 2, x plus 3. So that's what this is gonna factor to. So if I look at this one, it's only missing one of the factors. If I look at this, it's missing the other. That is my least common denominator. Because all of these factors contain all of the other denominators. So I'm gonna go ahead and rename the entire equation with that as the common denominator. That means no change to the first fraction, other than I rewrote the denominator to the factors. Alright, the second fraction. There's what it looks like. What is missing out of the denominator to make it look like the common denominator? Which factor is it missing? On this second fraction, which factor is missing? The x plus 3 factor. So I'm going to stick the x plus 3 factor in, and what I do to the bottom, I have to do to the top. Here's the last fraction in my equation. What's missing out of its denominator to make it look like the common denominator? The x plus 2 factor, so I'm going to throw that in there. What I do to the bottom, I have to do to the top. And now I can ignore the denominators and work with just the numerators. So my equation becomes this. Which now I have to solve for x. Which looks like a mess, but here it's just distribute, collect like terms, see what you have. If I have just x with no exponent showing, then I can use all of my normal tricks of add and subtract and multiply and divide. If it's an x squared, then I would need to factor or complete the square or quadratic formula. Okay? I'll do this one real quick just so you can see it to the end. Yes? Yes. All right. As I'm doing it, please review my arithmetic. Me and multiplication are not friends. Okay, I think I want to factor. I think I want to factor because factors of negative 14, 2 and 7, that when I add give me negative 5. Positive 2, negative 7. Positive 2, negative 7. Zero product property. Solve each of those. So my answers could be negative 2 or 7. But now I have to check my restrictions. Looking back at the original equation, I'm going to look at my common denominator. Each factor of my common denominator could be responsible for creating a restriction.
X plus 3 plus 7.
Yep. So x is not allowed to be negative 2. X is not allowed to be negative 3. Looking at my solutions, do I have one of my solutions matching one of my restrictions?
Yes,
Throw that one out. The answer is 7. That's it. The only way to make this more complicated is throw more variables at you. But the process remains the same. And you're welcome to use any one of those 3 processes that you like the best. We're going to look into the homework real quick just to talk about processes, and then we'll call it a day. This first one, it's fraction equal fraction. What's the easiest way to do it, get rid of it when it's fraction equal fraction? Cross multiply.
Oh,
Yep. Number 2,
cross multiply.
beautiful. Number 3, gorgeous. Number 4, You could cross multiply.
So you need to-
Yeah, but I've got an x squared thing,
so-
which is entirely possible it could make this a mess. So you can either cross multiply or you can rewrite this, like factor this, and rewrite it so that this becomes a common denominator. And then get rid of the denominators and go from there.
1 negative 2.
Do me a favor, I had a typo. There's like 2 symbols here. Can you get rid of the minus sign for me? On number 4. On number 4, sir? On number 4, get rid of the minus. I had an extra sign in front of the 2. Good catch. Number 5. Yeah, like rename stuff? Yeah, I'm totally down for that. Number 6. What do you think? It's not cross multiply, right? We could set it up to be cross multiply. Oh, that looks like it would be a mess, right? Okay, so maybe not set up for cross multiply. And it's not already set up that way, so maybe rename stuff? Alright, so there's another rename. Alright, and then just the last 4 on the back. Okay, use that same thought process you just did. Decide which technique you're going to use and then go for it. That's it, that's all I had. Thanks.